Hello everyone. In our previous video, we have covered till question 3 of the practice set 1. And so in this video, I'll be continuing with the question number 4 of the practice set 1 only. Question number 4 and 5 we'll be seeing, and then we'll continue with the practice set 2. If you haven't checked out the previous videos of this series, then please go and check them out. So let's begin with this video. So our question 4 is, what is the largest number which divides 62, 132, 237 to leave same remainder in each case? Okay, so we had seen this type of question previously, right? If first thing that they are asking you the largest number, which hints us that we need to find out the HCF, okay? But you simply need not to find out the HCF of these numbers, because it is also saying that it should leave the same remainder in each case. Okay, if it was asking you only the largest number which can divide all these numbers, right? If it was asking you the largest number which can divide all these numbers, then we would have found the HCF simply, because the largest number which can divide any given numbers is the HCF. But here it is also giving in the question that this largest number divide these given numbers and leave the same remainder in each case. So we had seen then that in this type of question, what we do is we first find out the differences of all the possible pairs. So how many possible pairs are there here? 62 and 132 is a possible pair. Then you have 132 and 237 is a possible pair, and we have 62 and 237 is another possible pair. Okay, so these three pairs are possible. We'll find out the differences in each case. What will be the difference here? 132 minus 62 is 0, and 13 minus 6, here we got 70. What will be the difference in this case? 237 minus 132 is going to give 105. And then what is the difference over here? It is 7 minus 2, 5, and 13 minus 6, 7, and then we'll be left with 1. Okay, so these are the differences that we got. Now you need to find out the HCF of these differences, and that will be our answer. Okay, if you remember, this was one of the types we had seen for HCF, that if it is asking you that you need to find the largest number which can divide some numbers and leave the same remainder in each case, then you need to find the differences of all the possible pairs, and then you need to find the HCF of those differences. So that HCF will be the largest number which will divide these numbers and will leave the same remainder in each case. Okay, so I will find out the HCF of 70, 105 and 175. Okay, so we'll be using the reduction method here. First, I can see that I can divide by 5 over here. Okay, so what we'll be left with? Let me use that blue pen. So 5, that is 70. Okay, so it will go 14 times. Then next we have 5 2s are 10, 5 1s are 5, then we have 5 3s are 15, and 5 5s are 25. Now what will be the next HCF? As you can see, 14, 21, 35 all are divisible by 7. So we will divide by 7 here. So we'll get 2, 7 2s are 14, 7 3s are 21, 7 5s are 35. Now we got all prime numbers. So here my HCF will be 1. Okay. So what will be my final HCF? I will multiply with the numbers with which I have divided. So 1 into 7 into 5, and that is 35. Okay, so 35 is my answer. 35 will be the largest number which is going to divide all these three numbers and is going to leave the same remainder in each case. Okay, so that is how we do this type of question. Now let's move on to the next question. So here is our next question. The next question is, find the smallest number that leaves a remainder of 4 on division by 5, 5 on division by 6, 6 on division by 7, 7 on division by 8, 8 on division by 9. Okay, so this question may look weird when you see it, but it is actually very easy question. Okay, what is there? It is asking you smallest number, so we got the hint that we need to find out the LCM. Okay, now it is leaving a remainder 4 on division by 5. So with the division by 5, it is giving you the remainder 4. Then it is saying that 5 on division by 6, so on dividing by 6 it is giving us the remainder 5. Okay, 6 on division by 7, so when you are dividing by 5 you are getting remainder 6. 7 on division by 8, so on dividing by 8 you are getting 7 remainder. On dividing by 9 you are getting the remainder as 8. Okay, so in each case we have been given the remainders, and we have seen this type of question. What we do is, you need to subtract the remainder from the respective numbers. Okay, and you will get a common difference. This type of question I had discussed when we were discussing the type of questions on LCM. This was one of the types, right? That if in each case you are given a different remainder, then you need to subtract the remainder from the respective numbers and you will get a common difference. That common difference you need to subtract from the LCM of the given numbers. Okay, so let's find out the common difference. 5 minus 4 will be 1. Similarly, 6 minus 5 will be 1. 7 minus 6 will be 1. 8 minus 7 will be 1. And 9 minus 8 will be 1. So the common difference that we found is 1. Okay, so now let's find out the LCM of 5, 6, 7, 8, 9. Now here you can simply go for the prime factorization method, as the numbers are very small. So for 5 it is 5 into 1, the prime factorization. For 6 it will be 2 into 3. For 7 it is 7 into 1. For 8 it's 2 cube. And for 9 it's 3 square. Okay, so now what will be my LCM? My LCM will be 5. Okay, we'll take the highest power from all the numbers present, so we'll take 5. Then for 2 the highest power is 2 cube. For 3 it is 3 square. And for 7 it is 7. Okay, anything is left? I think I have taken 5, 2, 3, 7, 2 and 3. Okay, everything is taken. So we have 5 into 8 into 9 into 7, which is 40 into 63, and that is going to give me 4 3s are 12, 4 6s are 24 and 1 25. So 25, 20. This is the LCM of the given numbers. Okay, 5, 6, 7 and then 8 and 9. We have found out the LCM of the given number. Now simply subtract the common difference from it. So just subtract 1 from it, and there we get our answer as 2519. So this is my answer, right? We had discussed this type of question. You simply need to find out the common difference. Okay, if we have been given different remainders in each case, then I told you in case of LCM, on subtracting those remainders from the respective numbers, you will get a common difference. So you just need to find out the LCM of the numbers, and at last you need to subtract that common difference from the LCM of the numbers, and you will get your answer. So 2519 is the smallest remainder that is going to give these respective remainders in case of these respective numbers. Okay, so I think it's clear. Now let's move on to the next question. So now we have come to the practice set 2, and we'll be seeing the first question from practice set 2. The question is, what is the least amount that a person can have such that when he distributed it into groups of rupees 16 or rupees 18 or rupees 20 or rupees 25, he is always left with rupees 4. Okay. So here least amount is indicating to us that we need to find out the LCM. Also I have told you that when we are talking about distribution into groups, okay, when we are talking about groups, this also hints to LCM. Okay, so you need to find out the LCM of these given numbers. Okay, then only we'll be getting the least amount, because LCM is the least common multiple. So for finding the least amount, you need to find out the LCM of 16, 18, 20 and 25. So let's use the division method. 2 8s are 16, 2 9s are 18, 2 10s are 20, and this is 25. We'll copy as it is. Now we have 2 3s are 8, 9, 2 5s are 10, and then you will have 25. Next we have 3 1s are 3, 3 3s are 9, 5 and 25. Again we have 3 here, 1 1 5 and 25. At last you will have 5 and again 1 more 5. Okay, this last 5 is going to cancel out all these. We'll get all ones. So what is my LCM? 2 into 2 square into 3 square into 5 square. Okay, that is 4 into 9 into 25. So what is the LCM? 9 4s are 36 into 25 we have. Okay, so what will be the product? 36 into 25 is 5 6 are 30, 5 3s are 15 and 3 is 18, and 36 2s are is nothing but 72. Okay, so we have 900. 900 is my LCM. I think I did something wrong. It should not come out as 2 square into 3 square into 5. 9 4 5 6 are 30, 18, 2 6 are 12, 2 3 are 6 and 1 7. Okay, I'm really sorry. This is 2 4s are 8, not 3s are 8. Okay, 2 4s are 8, and therefore we again will have one more 2 here to cancel out this 4, and again 2 2s are 4, so again one more 2 will be there to cancel out that 2, and then we'll have this 3. So we have missed out 2 times 2 over here. We'll have one more 2 square, and therefore that will contribute to 4. So the product, the LCM will be 3600 and not 900. Okay, this is not 900, but it will come out to be 3600. So okay, so LCM of the given numbers is 3600. Now 3600 is LCM of these numbers. That's why 3600 will be completely divisible by the given numbers, right? So if he has 3600 rupees with him, if the least amount that he has is 3600, then if he is going to distribute this 3600 into groups of 16 or 18 or 20 or 25, he'll be left with no money with him, because 3600 is completely divisible by these numbers. So if he distribute the 3600 into groups of these given numbers, then he'll be left with no money, because 36 will get completely distributed into 16 or 18 or 20 or 25. So he'll be left with nothing. But in the question it is mentioned that he is always left with rupees 4. That is, when he is distributing this money, whatever money he has, when he is distributing it into the groups of these given numbers, Okay, he is left with rupees 4. So what we will do is we will just add 4 to 3600 and we will get 3604. Now this is the least amount which if he has, then if he distribute it into a group of 16 or 18 or 20 or 25, he will always be left with rupees 4, because this 4 is the extra part, isn't it? 4 is this extra part, because 3600 will get completely divisible as it is the LCM of these numbers. So this part will always get divisible, and therefore 4 is the extra part which will always be left as the remainder, or 4 rupees will always be left with him. Okay, so I think this is clear to you. Now let's move on to the next question. Or I am finishing the video here. Okay, I'm thinking that I should finish it here. I don't want to make a very big video because this question is really important and it is going to take time. So I'll continue with this question from the next video. So it will be, the next video will be a continuation of this practice set 2. Okay. So in this video, if you like my work, then please like, share and subscribe the channel. And then I'll see you next time. Thank you.